Hi everybody. I stopped my video partway through. Actually, my wife had a meeting at the same time, which is why we did that. And then I realized or reflected on this and thought, hey, I actually need to clean up some of that code. I don't want to give an answer to a quiz that we're about to do. And on top of that, there's a little bit of a quirky thing going on with that code. So let's have a look. Let's just quickly revisit what we were looking at with the student class, and then I'm going to refactor the rectangle class, the Rect2400 class. So here is what we were doing. I could make either a blank, just a student, and I'll call the default blank constructor, or I can make a student. Oh, by the way, if I wanted to make a constructor, let's do it this way. If I wanted to call another constructor, I can do something like this. But if I don't have, so I can do something like this, right? I can call the constructor by just putting the extra parentheses in there. This doesn't come I'm always amazed by this whenever I start teaching this. I'm like, why do we always emphasize this version of things? And I keep coming back to, well, I will often need an array of different things, and I will have I'll have a group of students. I don't know how many students I have. I make an array. I put a bunch of students in that array, and if I'm doing that, I need to use this form of constructor. I need to call new versus just having a default set number of students. This comes up again and again and again, where I don't know how many objects I'm going to need, and so I will make an array bigger than what I need, and I will I will instantiate instantiate meaning make an object. I'll instantiate this class. I'll make objects of this class until the number that I need at the time, not just blindly make 4,000, 4,000 objects just in case I need some of them. So if I have cases like, oh, let me think of some examples, like our linked list class, like our where you have a tree data structure, at least unless I change the assignments around, we should have a tree data structure where I don't know how many nodes I need. I don't want to make 4,000 nodes and only use some of them. What I want is an array of pointers to nodes or pointers to tree nodes or whatever I'm making. And if I only use the first 200 of them, I fill in the first 200 pointers, and the other 200 pointers, or whatever is left in my array, that will be full of nulls. So I can do a smaller number than some maximum number. It comes up again and again that you will actually need this format, not this. So I just want to make sure that the expectations are set correctly. By default, you're sort of going to be doing this kind of thing a lot of the time, especially when we're talking about drawing shapes or anything like that. Anything with a little bit of panache to it. Anything with any kind of problem that is not just some trivial Troy problem, you'll probably need to use a dynamic object. Okay, so here's what I'm doing. I can make an object called stew. I can make an object called pstew. This is a pointer to an object with these parameters. I can get the ID. I can set the ID. I notice I commented this out because we're going to be discussing this later. Get name, set name, I've removed them from our code base. So set name and get name, they're going to be here, but I've actually deleted the code itself for set name and get name because that's what the quiz is going to be. So let's, instead of looking at this, I'm going to save all of this. Let me pull up Rectangle 2400 instead, and let's refactor Rect 2400. We have Rect 2400 already, so let's see where it is. Rect example. This should work, right? Okay. Here's my Rect 2400. And I had a structure, and this is the way I would have done it the old struct way. We have this new version of it. By the way, that pop-up is always me. I synchronize with my Google Drive, which allows me to pass off the links to you guys, which is why you might get those pop-ups. Okay, we have a structure here. What I want to do is what I'm going to do. So let me walk you through this. I am going to make a brand new class called a Rect2400. I am going to take all of this code and move it over to Rect2400. So let me just, hopefully, I'm not going to blow anything up here. I'm just going to rip all of this stuff out. I'm now going to make a new class, so add class. So if I add a class, I'm going to get a header file and a CPP file because that's what they expect me to do. Everyone expects when you make a new file, make a new class, you make a header file and a CPP file. I'm going to call this class Rect2400. Notice the capital letter at the front saying, hey, this is the name of the class, not an object. I don't have a base class. We'll talk about inheritance soon enough. I'm going to make a header file and a CPP file. Okay, all the other options you can leave blank. So here is Rect2400. Notice I have that pragma once thing again. And again, if I get rid of that pragma once, weird stuff is going to happen. Okay, I'm going to just copy this over right in here. Let's see it in action. All right, so I have my struct, I have my class Rect2400. I can put the struct right in here if I wanted to so that people can see what the color is. I have private member variables, meaning nobody else can see those member variables. No one else can get the x, y, width, and height for my rectangle. Only the rectangle knows about what its dimensions are. No one else has direct access to it. So if I go to rect example and I've already made one of these things here, save it, and I'm also going to have to include. I'm going to need to include Rect2400H. You will notice something also a little weird, and I think I have slides on this, but let me just go over it now. You'll notice something strange. With my included header file, sometimes I have quotes, sometimes I have parentheses, these angled parentheses. What is the difference? One way of looking at this is the files that you are not making yourself, angled parentheses. I didn't make IOStream, angled parentheses. Stuff you made yourself, put it in quotes. That's not actually what's happening. What's actually happening is this is looking for it locally. It's looking in this particular solution for this particular file. This, on the other hand, with the angled parentheses, is saying go to where we put all of our main libraries, all the extra, the sort of the place where we store all of the extra code from other projects, all of the pre-canned solutions, where the vector class is made, where the string class is made, all of that. It's in one directory somewhere on your computer. Visual Studio set that up originally when you installed Visual Studio. It is the default place where it looks for external libraries. Go look in there for assert.h. Not in my project itself. Go look somewhere else in some main default place, much like where you put when you make a video, or let's say make a video, it gets saved in the videos folder. It doesn't get saved somewhere else on your laptop. It gets saved in the videos folder. That's the same sort of idea. Okay, so I'm going to include Rect2400 here. Save it. All right. Let's also go down here and let's see what happens. So I have my rect. I'm going to make a new rectangle. Great. I'm going to say my rect, and let's do this slightly differently. Let's make a dynamic rectangle just to equals new Rect2400 with these parameters. Great. Notice, by the way, why I put things on new lines. I could do that as well, just to clean up my code a little bit, or I could make a what did I call that? This is actually what I'd normally do. Our color, I'm going to put the U in there because I was living in the US for too long. I want to put U in color from now on. All right. Semicolon. Our color. You probably wonder, why am I doing this? Notice how much space I have here, right? I never want to have this automatically wrap around. In case you're wondering, for just stylistic purposes, I don't want this to auto wrap to the next line because I'm not going to be able to understand a damn thing that's being said. So that's part of this. So I want to do this. I'm going to find this my rect, and I need to actually, let's do what is going on with my mouse. So I'm going to do a find and replace. I'm going to say my rect dot, and I'm going to replace it with p my rect arrow, and return, 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 return. No more occurrences. Fine. Close it up. That should do it for me. Okay, that works. Okay, so what do I have here? I made a new color just because I wanted it not to do a line wrap. I put that new color in as one of my parameters for my new object I'm creating. I also, now that I've called new, I need to call delete p my rect. Just get into the habit, and then I want to say p my rect is equal to null. I don't need to do that, and I return 0. At the end of my program is done. I don't actually need to do this final part, but get into the habit. Make sure if I delete something, I clean up the pointer. Just it's bookkeeping. It's being safe. Okay, not a lot has changed from what I had before. The difference is, so let's go back to what I was originally doing. All I did was take my original code and stuff it into a new file. That's not going to work, if you couldn't tell. What it's going to happen here is this is not going to exactly work, at least. I'm going to go, instead, I'm going to take my functions themselves. I'm going to just stuff them over here into this class here. All right, so notice it's including the header file that I need. So it's going to include all that header file stuff. And then it's going to, here's the definition of my functions. Here are my functions again, but I'm actually just going to put little stubbies everywhere, right? This I owe you one function named rect area. It'll be defined somewhere else. I owe you one function named intersect. It'll be defined somewhere else. Why do I do this? Because if you have, honest to God, if you have, let's see, way back in the day when I was doing the children's educational video game, we had 500,000 lines of C++ code. Every single time you did a full clean rebuild, you can go off and have a sandwich. It'd be about 10-15 minutes of rebuilding and linking everything up. Because if I change the CPP file, I just change the one object file. I change a small little part and everything still works. If I change the header file, everything from the very beginning has to be completely rebuilt. That's the reason why we do it that way. So here is, I want to actually, let's also put in this Rect 2400. I want a default constructor as well while we're at it. Why not? Okay, and let's save it. Let's just save all. I'm going to go to my CPP file. I'm going to put in my default constructor. And you'll notice something weird. It doesn't look right. Why? Because I need to say, look, where is this class that I'm defining the functions that I'm going to need. This is the IOUs. I owe you a function named constructor named Rect2400. When I define it, I have to say, where is that? What function are you defining? Oh, I'm defining for the class Rect2400. I'm defining the default constructor. For the class Rect2400 in the header file, I'm defining this constructor. For the class Rect2400, so this is saying, where am I looking? In this particular class, I'm defining this function for that particular class. I'm defining intersect for Rect2400. All right, and I need to do a couple more things here. X is equal to 0, y is equal to 0, w is equal to 0, let's say h is equal to 0. I can have a rectangle that is of no size. And color, do I have a color called color? RGB. RGB is equal to, I'm just going to steal this thing from the Rect example. It's the color white, in case you didn't know. 255, 255, 255. It means all the colors are full color. So it's the color white in this case. And I'm just going to stuff that in here. And here we go. So lazy, I am so lazy. There we go. Okay, so I have a constructor that is a blank constructor. I have a constructor that takes in a bunch of parameters. I have something that will get the area. I will have something that does the intersection. Let's remove that. And hopefully, if I did everything right, when I run this code, I don't trust myself, but when I run this code, I should get the exact same results as I had last time. The exact same thing I had before when it was all in just one file is now distributed across two files. I have a what this thing looks like. Here are the functions available to you. Here are the variables in there, but you can't modify them yourself. And over here I have now this rectangle itself. You can get the information for it. Let's do, I can do a couple other things, but let's just look at my example here again one more time. Okay, I want to show you this. So let's do p my rect. Let's just get the variable. Wait, I can't. Where's x? Where's y? Where's width? Where's height? Where's the color? When I'm looking for what's left with a structure, when I would put like a dot or an arrow, I'd get here are the variables available to me. They're not listed at all here. Autocomplete's not finding this thing at all for me. It's just giving me two functions. It's giving me just two functions because of this. Those are private. When you actually are doing autocomplete or trying to use something, it won't even let you see them. The x, the y, the width, the height, and the RGB value. The only way to access them is through some method. And when we talk about getters and setters, that's what we're going to be talking about. What I want to do is hide away the details so that no one knows what's inside this class, and then just use a method. So I can't actually directly access those variables. Let's change things around one little bit. I'm going to go to my header file. I'm just going to pull off the height. Why? Because I can. Okay, I moved one variable. That's all I've moved. Nothing else should change. Everything should compile just fine. If I go to my example again and I go p my rect and then this, hey, look, I can directly access and modify the height. So let's do that. I'm going to modify the height to be equal to, right now it's 100, 100. I'm going to make it 2000. And you're probably wondering, what's so wrong about this? Well, what gives the main method, or what gives somebody else the right to modify my data? The rectangle should know when it modifies. Let's make it a negative value. Oh, there you go. Let's really screw things up. Negative 2000. So the RGB value is an integer. I'm going to make the height a negative value. The area, this is going to blow up because it's saying the area should be 10,000, right? Because of this. But I willy-nilly just added, I just directly modified some variable, and you had nothing to say about it, right? The object had nothing to say about it. You just directly stomped on and changed some value. And by the way, you should never be able to get a negative height. So we need to work around that. So let's blow up our code right now. So I'm going to, first of all, let's comment this out. Let's have it run. Hey, works as you expected, right? The size is 10,000, the area is 10,000. It works exactly the same as last time. And explosion, right? It's saying rect area is not equal to 10,000, and it blows up. Why? Because I stomped on the value, the width on this thing here. So if I expand this thing out, here is the height, negative 2000. For p my rect, the height is negative 2000. Why? Because I just willy-nilly stomped on some value here. I shouldn't be allowed to do that. That's where we're going to get to with getters and setters. So let's stop that. I want to get rid of this. I definitely do not want to be exposing that header, that height value to being public. I want it being in private. I want to make sure that nobody else has access to it. I don't want you guys giving access to your student number to any to some random person on the street, right? You choose who you give your student number to. You choose who you give your name to. You choose whatever. Now that, that's a human conscious thing, but it's the idea is nobody needs to know what that height is, other than unless you explicitly say you're exposing it to somebody else. So here's what we can do if we wanted to do this. We can add other functions. I could say int get height, int get width. Okay, so get height and get width are going to give the height and width of this function. So let's go back to my rect example and int rect2400 get height. All right, int rect2400 get width. Return w. Great. And it should. R is undefined. Where the heck is this R coming from? Let's just save it and see what happens. Oh, it cleared itself up. So what is get height and get width? It's just returning the value, not the variable, the value for the variable for w and height. Let's go over this again, and let's say p my rect is equal, and then let's get the height. H is equal to negative 2000. What's going to happen? So think about this right now. I made a variable h. I get the height from the rectangle. Variable h. I change the variable. What's going to happen to the height of the rectangle? Will it blow up like it did last time? When I modified the height. I went in and modified the height. Oh, it's not in standard. It's syntax. Oh, there you go. Syntax errors. They happen. All right. Last time I just directly stomped on the h value from my rectangle. This time I'm getting the height, putting it in a variable h, changing the variable h. What happens? Let's find out. Nothing happens. Why? Oh, damn it. Stupid. Get Google back up. Okay. I'll have to clean that up in a second. Okay, there we go. Why? Because I'm making a brand new variable called h. I'm getting the value from get height, which is just the value, not the variable itself. I'm setting that value, this new variable h, to whatever that value was. So in this case, 100. The value of h is 100. I set it to negative 2000. Who cares? I'm allowed to set it to negative 2000. It's not going to be used at all. The variable, the height in my rectangle has not changed. The rectangle still has that 100. I just passed off a copy of the value. I passed the value back. I didn't give access to the direct data. Getter methods allow you to get access to what the values are, but it doesn't mean that you give edit access. So you can see what the value is now because it passes off the height, for example. Get height gives me back the height, but it doesn't allow you to directly modify the height. Okay, well, let's do one more thing. Let's go and directly modify the height because, I like screwing things up. So here's where a getter method would be. Getter methods normally have a void. Sometimes you can have a boolean or something, but void is fine. Set height, and it's going to take in some value, int new h for my new height, something like that. Okay, I'm gonna screw myself over just the same way as I did last time, just to show you this in action. Okay, so I'm gonna put the get rect in here. So everywhere I have, for every single function, I essentially have a duplication. I have the original little prototype thing, and I have the actual implementation. Okay, h is equal to new h. Great. So why would I want to do this? So I have a setter method. I go through the setter method, make sure that, and so I get a new value. I set the header file to this new value. And let's change my code here. So p my rect. I want it to, this is going to hopefully blow up in my face. Set height, and I'm going to put h in there, right? I'm going to set my height for my rectangle, for my this rectangle here. I'm going to set the height to being negative 2000, whatever this value was here, right? And again, the arrow should be wrong and things should blow up. So I'm expecting this not to work. But we'll have one more step after this. So I'm expecting an assertion failure because the height is going to be negative 2000. Yep, there you go. It blew up. Nice. Blew up because the rectangle, if I look at my p-rectangle, hey, the height is negative 2000. Set height actually works. But why the heck should it be allowed to have a negative height? That makes no sense. Heights and width should be absolute values. It's either 0 or it's some positive value. You don't have a negative height on some, well, you could, I guess. But really, you could imagine the height being just an absolute value thing. Or maybe you're not allowing it to be. So the x and y coordinates must be the upper left-hand corner, and the width and the height have to always be positive values. We could make that assertion. This is where setter values come in handy. So I have a way to get stuff safely without modifying my data or giving access to my data. I just pass the value back so other people can see what the data is without being able to directly modify what my object has. And I have setter methods, so I go through a function to set a value. And the reason I do this is like this. If new h is less than 0, I can either absolute value it. H is equal to h, let's say negative h, right? If it's a negative value, is it equal to negative new h, sorry? If it's a negative value, make it a positive value. Or I could say it's equal to 0, or I could do all sorts of things. This is an error check. I'm doing an error check here, and otherwise, let's do an else. All right. Otherwise, I'm just going to set the value. Fine. If I don't want people to be able to set the height at all, or the height has to be between 10 and 2000, I could do that. All the error checking, all the logic for making sure that the data is in the right format can be done in a set method, done once. And now I can just keep on calling set height, set width, set x, set y, and it's going to work. So let's throw a couple of these other ones in there. I'm going to do set width, height, x and y. Yes, I am that lazy. New x, new y, new width, new height. Maybe I want something like this. Okay, so in this case, I'm going to go back to my Rect2400.cpp example. I have this set height thing. I'm going to, I'm extraordinarily lazy. I'm just going to plop this down here. I'm going to make sure I have the right parentheses. There you go. Well, maybe I want to make sure that the new x is absolutely positive. So if new x is less than 0, new x is equal to 0, else new x, oh, actually I could do that. So if new x is less than 0, I make it equal to 0, and x is equal to new x. Something like that. I can do the same thing for y. And, oh, there's a semicolon at the end. I don't want that. Y So I can just error check when as I go. And again, we'll see one more example of this, and I'm going to use the same error check for this. This is where I get in trouble because my copying and pasting means I invariably will forget one at some point in time. These things happen, but okay, it's faster. Okay, so I check to see if the value is less than 0. If it is, I flip it around. So if it was -10, it's now +10, and I set the width. Otherwise, if it was 10, I keep it at 10. And I'm going to do one more thing here, just to see if I can save myself some time. What I might want to do here is in Rect2400, might want to say set x pause, set y pause, set w width, set it's set height and set width. And I might want to do this because I can do all sorts of stupid things with my code. So let's take another example and let's make something garbage. So I'm going to use the same RGB values. I'm going to make a brand new, call my Rect2 because I'm very original. I'm going to make it -100, -200, -100, -200. All right. What would I expect here? This is going to update everything. So I start at 0, 0. I have width 100, height 200. That's what I would expect this thing to do now that I have this error checking. And let's put a breakpoint right here just to see what happens in the end. And then let's also set the height be my Rect2. Actually, let's make the my Rect2 equal to that, just for fun. My Rect2 is equal to this whole thing. Oh, that's y. T. All right. I made a little minor change. I then check my code. I make a little minor change. I check my code. You can even do smaller chunks than this. Do each function one after the other, not 4 at once. Do not write all your code and then check afterwards. And I figure out what I would expect to see. I want some tests, so I expect this thing to be 0, 0, 100, 200. Then I'm going to set the height, and instead of 200, it's going to be 2000. So the new height after I do this should be 2000. So 0, 0, 100, 2000 by the end of it. And that's what I expect this code to do. So I test. Let's run it. So let's have a look at what my Rect2 looks like. My Rect2 is down here. It's 0, 0, 100, 200. Hey, that's working exactly the way I expected. I go one step further. It's now 2000. Everything still runs because I'm modifying my Rect2, not my Rect now. But still, I can check to see that my set methods are actually working as I expect. I am checking for errors in one place, not in 40 different places. By letting the rectangle control how it changes, how you set things, it means you can error check in one place versus 4,000 places. Double checking, triple checking, quadruple checking thing. No, just have the rectangle check itself. It amazes when it finally comes into focus and you realize how this actually works. It's really a beautiful thing. Okay, I'm going to let's finish off what I was going to talk about for object-oriented programming for a little bit, and then we're going to look at what we're doing for the quiz. So we already looked at refactoring this. We're going to be we actually looked at this code as well. We're going to look at this for the quiz. So for the student class, which you have access to, what we're going to, and I'm not sure, I have to double check this particular slide. What we're going to do is you're going to take the students.cpp, student.h. I would like you to grab those files. I want you to grab class 6 essentially. I can say class 6 here just so I don't forget later on, which is where the student code is. I want you to grab those files, have a look at them. I then want you to add, as an exercise, I want you to add get name and set name. Now, in the header files, set name will look like this. It will take in a character pointer and a void, so it's going to change the name in the student class. Get name will return a pointer to the name. That get name is actually going to be a problem, which we will see soon enough when we talk about pointers and the little weird edge cases that we end up having. But for the time being, until the quiz is over, write it this way with get name and set name that way. Because what I want you to do after that, once you're finally done implementing this, the quiz will be, what is the CPP files version of set name? What does it look like? If I implement that, that function in student.cpp, what does the top line look like? Right? It should say student in there, student colon colon, that sort of thing, right? What does the function set name look like in the CPP file? Okay. What I want for take-home lessons really right now is we're just getting started with an object-oriented perspective. We talked about classes, which is the sort of the blueprint for how the data and the functions work together. Objects are instances. So an example like the PMyRect2, PMyRect1, they are instances of that class. They are independent of each other. When I change one, I don't change the other one. That they are objects. And classes are just bundles of data and functions. Why it's important is because you'll see it in weird, wonderful ways where you get to control your own data, and the way you view the data itself will be, I think, more intuitive. Uh, Ideally, the data should only be changing in the class, and we'll see this very, very soon. And the data should not be visible to other classes. That control, that sort of rigor that you're providing to your code, that's the difference. You could do it yourself in C, but nobody does. Nobody is that, you know, um, determined and that methodical, right? People make stupid mistakes all over the place, or they just make a little shortcut one time. It's just one time shortcut. I'm only going to cheat on my diet this one little time. And so this sort of forces you into a particular habit that we know is good for good coding habit. Okay, so when we come back, we're going to look at access control, we're going to look at information hiding, and separation of concerns. All right, thanks everyone.